Hey folks, Professor Gray here, ready to talk to you about hypothesis testing. Well, I'll be giving you an intro of hypothesis testing, and then in videos to follow, we'll continue the process and do more of it. First of all, note that in inferential statistics, there are two major activities that we cover. One of them is estimating the values of population parameters. We do that with point estimates and confidence intervals. And the other is testing hypotheses about population parameters. Well, that's what this particular set of videos is going to address. Hypothesis testing with one sample. So we'll try to make generalizations and test hypotheses and make decisions about the population mean and the population proportion. Hypothesis testing uses the rare event rule for inferential statistics. That's the theoretical basis for all of this. It says if under a given assumption the probability of an observed event is extremely small, then the assumption is probably not correct. That's what we'll be doing. We'll make an assumption, or at least state a hypothesis, and then we'll find the probability of some observed event. If that probability is small enough, then we will reject this null hypothesis. The event is called statistically significant if we are able to do that. So here are some terms that we'll use in hypothesis testing. First off, a hypothesis is a claim or a statement about a property of a population. Some statement about the population mean or the population proportion in our case. The null hypothesis is the hypothesis that involves a statement of equality, and we denote that with an H sub 0. 0 is another word for null. This is the hypothesis that we will be assuming to be true and trying to disprove using the rare event rule for inferential statistics. The alternative hypothesis is the hypothesis with a statement of inequality, such as a not equal to, less than, or greater than. And that's denoted H sub 1. Now some textbooks denote that H sub A for alternative. For consistency, these slides will use H sub 1. Throughout these videos, we'll be using this running example. And by that I mean that I'll go to the example throughout each part of these videos. We'll keep working the same problem, explaining different aspects of this process, and then returning to the problem to work out another part. The scenario is a magazine claims that 63% of people in the U.S. are in favor of outlawing cigarettes. You decide to test this claim and you ask a random sample of 200 people in the U.S. whether they are in favor of outlawing cigarettes. Of the 200 people, 98 are in favor of outlawing them. So at a 5% significance level, we will test the claim of the magazine that 63% of people in the U.S. are in favor of outlawing them. Well, here's an overview of the procedure we'll be using to do that. The first step is to identify the type of hypothesis test that's involved. We'll be studying three in particular: a z-test, a t-test, and a one proportion z-test. We'll then identify the null and alternative hypotheses. We'll label them, and we'll label which one is the tested claim. We'll read the context to be able to determine the tested claim. Then we'll gather sample data and calculate any test statistics. We'll use that to find the probability of the sample data occurring under the assumption that the null hypothesis is correct. That's the assumption that we are making and trying to disprove using the rare event rule. Now, we won't really gather sample data. Most of the time, we'll just read about it in problems. but we will calculate the probabilities of those sample data occurring. We'll mostly use the calculator to help us in those calculations. Two more steps. If the sample data is rare, we'll use the rare event rule and reject the null hypothesis, the one we've assumed to be true. Otherwise, then, well, we fail to reject the null. We can't rule it out. We'll get into more of what exactly constitutes rare and how we can determine that. Then we'll interpret the results of the test in terms of the original context and claim. So those are the 5 steps of this hypothesis test. Let's go back to our running example. We'll identify the null and alternative hypotheses. To label the hypotheses, I use H sub 0 for the null and H sub 1 for the alternative. This particular hypothesis test is talking about a proportion, 63%. So I'll use the symbol for population proportion, lowercase p. And the claimed proportion is 63%, or 0.63 as a decimal. The symbols and that number must be used in both hypotheses. The null hypothesis, H sub 0, always contains a statement of equality. Now, some textbooks insist upon this statement being an equals sign or symbol. And that's what I'll use in these videos. Some textbooks also use less than or equals to or greater than or equals to. And that's okay. But these videos will just use equals for the null hypothesis. Then H sub 1 uses a symbol of inequality, either less than, greater than, or not equal to. In this particular problem, we're not looking to see if the true proportion is less than 63% or greater than 63%. We would just like to see if it's anything different than 63%. So we'll use not equal to. That's anything other than 0.63. Now, if you read the problem again, it says at a 5% significance level, test the claim of the magazine. So the magazine is the claim that we are testing. It's often helpful to label that tested claim at the very beginning when you label the hypotheses. H sub 0 in this case is the tested claim, that the proportion is equal to 0.63. So I want to put a C in parentheses next to H sub 0 to label it as the tested claim. And that will help me later on when I interpret the results of this hypothesis test. More of the process in the next video.